got a question about this example. It was in 3.3, and it's that 1 minus a is a factor of both the rows. So then why do we have the 1 minus a twice out here? And it's because, simply enough, each row contributes a factor to that determinant. Okay, so since 1 minus a is a factor of that first row, we get a copy of the 1 minus a here. But now since 1 minus a is also a factor of the second row, we get a second copy of that. It's just that for every multiple of a row, you can pull that out. Now, the reason being is that if you do your cofactor expansion along, so let me use an, well, let's just look at this one, okay? If I were to kind of do it the long way, okay, and we had a times a minus 1, just recopying here. Let me write it just the same way, 1 minus a, 1 plus a, 1 minus a, 1 plus a, minus a, and it's 1a, 1. If we want to determine that, I mean, that's a 2 by 2 matrix, okay? We multiply, right, these together, okay? So that's going to be a times an a times a 1 minus a times another 1 minus a, right? A minus, and then the product of the other ones, right? 1 plus a, 1 minus a times 1 plus a and 1 minus a, right? So notice when we multiply the top row times the second one, we get a 1 minus a squared in both cases, okay? So when it's a factor of one row, it's going to be a factor of the determinant. If it's a factor in two rows, you're going to get it twice because you're multiplying it by itself, right? And so I could, just to show, if I took out both of those copies, I'd have a times a minus 1 plus a times 1 plus a. Okay, now that is exactly the determinant of, and I can't write this, and I put 1 plus 1 up there, it's an a, of that determinant, right? And it's because when you're multiplying them out, you're multiplying it twice, once for each row. Okay, that's why that rule says if there's a scalar multiple of a row, okay, or a column, okay, you can pull that out and calculate the determinant. It's not saying that the matrices are equal. It's saying they have the same determinant, right? Okay. So I mean, that's just a little bit of an explanation for that rule. I hope it helps clear it up a little bit.